So, if you're freaking out about the calculators, we just have a little handout we're going to work on about what we're going to go over today. There's no pop quiz or anything. I don't like doing that. So if there's no questions on anything, I'm going to real quick remind you of what we did last time with the very last thing at the end of class. We talked about something called expected value. I'm not going to run through the proof again, the math of why it works, but basically if I have let's say I talk to a lot of people, and I ask them, how many TVs do you own? So this would be the number of TVs, that's their answer, the number of TVs they own, and this is going to be the percentage of the people that said that number. So let's say 11% said they have no TV. Exorcist for this. Let's say, what do you got? 34% of people said they have one. 31 said they have two. So then, what would the last one have to be?
Something that makes it add up to 100%.
Sweet.
I don't know the number though. So.
I don't know either. I'm crowdsourcing. Beautiful. So far I got 0.76, so 0.24 will make that become 1.
Yeah.
I like it. Kick ass. Yeah. Somebody ever seen this symbol here besides sororities or something? Sigma. This symbol means sum. Just in case I write it up here without even thinking about it. So if I summed up all of these, it has to be 1. So it's a quick way to say add up all the percentages, they have to be 1. All these probabilities. I like it. So what we learned last time is mathematically to find the average, all I have to do is multiply these together. Multiply the weight times the value. So 11% of 0 is 0. 34% of 1 is 34. That would be 62. And that would be 72.
And what are those now? What are those numbers?
These are like the weighted values. They're kind of like middle step. They're a middle step. By themselves, they don't mean much of anything. You with me? So this 0.62 by itself doesn't mean anything. It means how much this number contributes to the overall average. 31% of my numbers were 2. So they would have to be like 0.62 out of 100. So 62 out of 100, if there are 100 numbers. Because the funny thing is, what do we normally do to find, I really want this to make sense. To find the average, what do we normally do in English? Yeah, add them up. And then divide by how many there are. So what's missing here is I'm adding them up, but I don't seem to be dividing by how many. But what's always on the bottom of a probability? What's always on the bottom of a probability?
The total?
The total. Kick ass. So it's built in there. Dividing by how many there are is built into the probability. So it's not there. It's in there. All right. So real quick little thing here. This goes a little bit beyond what the book does. But what do you think I'd call this column? How did I get these numbers? How did I get these numbers?
Looks like you multiplied the first two columns.
Kick ass and multiply these to get over there. All right. That's what the math came out last time. So what do you think I label it?
P.
This is the x's.
X times PX.
Kick ass. I like it. So the book uses symbols like, well, they just use the same idea, but they use probability of A times A. Stuff like that. All right. So if you were here last time, we went over the math of why this works. Right? I love the idea that probabilities have n on the bottom. They already are divided by the total. That's why this comes out to be the average. It's already divided by the total. So what do you get when you add these up?
1.
Well, it can't be 1. Yeah, what's that represent?
The sum of.
So remember, what does that represent? So again, if I had 100 numbers, how many of them would be 1s?
30.
34 of them would be 34 out of 100. Oh, well, now if I had 200 numbers, how many would be ones? 68. All right, let me stop there for a second. Are you guys understanding? So what we did, maybe I should do what we did yesterday or the last time again. Because that's huge. It's the math of going from how we know to do averages when I have a list to what if they give me this? There's got to be math that's quicker. I don't want to make a list of 11 zeros and then 34 ones and then add them all up. No, I want a shortcut. So thank God we can manipulate math and see, is in this new situation, is there another way to do this? Another way to get the average? And yes, this is the way. If you have 11 zeros, 34 ones, 31 twos, 24 threes, add them all up, divided by 100, aren't they already all divided by 100?
Yeah.
So of course it's going to be the average because we just did what we said we're supposed to do. Add them up, divide by how many there are. I like it.
So what does that mean? The average is 160?
The average is 1.68. And look at your numbers. What are your numbers? What's this mean? What does that mean? Zero TVs. This guy had 0 TVs. Where should the average be? Somewhere in between 0 and 3, right? This is all the answers I got. 0s, 1s, 2s, and 3s. So the average number of TVs can't be 4. Nobody had 4 TVs, right? So 1.68 makes sense for a couple of reasons. What's the heaviest, the most number of people that had this many TVs? How many TVs did somebody have the most? How do I say that grammatically? What was the number of TVs that showed up the most? 1. So the average should be kind of close to 1. These pull it up a little bit. There were some 2s, there were some 3s, so it increased up to 1.68.
So the average person has 1 and 1/68th of a TV?
Well, 1 and 68 hundredths. So averages don't have to make physical sense. Thank God they don't. I don't want to see your 0.5 kid. Right? What the hell does that mean?
That's possible.
Keep them in the basement. No. But that's the thing. People confuse averages with actual physical amounts. Averages only make sense in terms of large numbers of things. Right? So if I had 100 people, how many total TVs would I have access through those 100 people? How much does each one have on average? I'd have 168 TVs I could access through those 100 people on average. Now it becomes a whole number when I start talking about large groups. Probabilities and averages don't make any sense when you think of it as one thing. I flip a coin once. What does 50% that it's going to be heads mean? What does that mean? It's going to be freaking heads or tails. It doesn't mean anything in that once, but if I do it 1,000 times, now it makes sense. I should get 500 heads on average. All right, let's try another one. So I'd say out of this sample of people I talked to, they had an average of 1.68 TVs. Kick ass. Nobody had 1.68. You don't say, well, it works about 4 days of the week. No. It's a TV or it ain't. Right? On Thursdays, it's a piece of broccoli. No. What the hell is that? Okay. So let's try another. Let's do something a little more close to home. Let's say you make an average of a 78 on your tests. You have an average of an 89 on your quizzes. And let's say you get a 84 on your final. What will your average grade be? Well, it depends on the weight assigned to each one. So this is not a probability, but the math doesn't care. The math looks at these percentages as weights. They still have to add to be 1. So the math still works. So if the tests are weighted at 50%, the quizzes, let's say, are weighted at 25%, and so the final would be weighted at what? 25%, so that this is overall 1. Take a minute and try to figure out what that person's average would be. Or stare at the board, I guess.
Yeah.
Now I want specifically. I want to know exactly.
each?
Yeah, hell yeah. So half of 78. So you just multiply across
39,
39. Good.
22, 25,
I like it.
21,
Yep.
and the total is 82.
So that's this times this is there. This times this is there. This times this is there. 25% of it was 89. Bam. So think of it like they're each contributing an amount that when added together will become the average. So this gets to contribute half of it. This gets to contribute a quarter of it. So forth. So then, what'd you say it adds up to be?
82.
82.25.
Yes.
Cool. I like it. So then you'd actually get a B, not a B minus. You kind of, you're really close. That's why I want to be able to, I wish I could take credit for making it that close, but I can't. I knew it was going to be somewhere around there, but I'm pretty close. You B, not a B minus. Yeah. Okay. I like it. I like it. So anything that can be written in this form, you can find the average of it by applying this. And again, the funny thing to me, I teach the same exact thing in statistics, and we do a lot more with it. But this is where we start. And remember, so the average, another name for the average was expected value. Which kind of makes sense. I mean, if I say the average number of kids a household has is 2.5, then that's the expected amount. If I went to 10 houses, I would expect to have seen 25 kids run around, right? Do you see what I'm saying there? So expected value makes sense. And watch this beautiful, what's the formula again? I add these up, so it's the sum of xp of x. And look at the first three letters of that. Freaking expected value. It's awesome. I love that. Anyway, all right, just for me. Cool. Anyway, so how much of this do you have to know? You don't have to know this little formula. You really don't. You don't have to know this symbol. You really don't. I just want to show you that's how we say it really quickly. Sum up something. You just have to know how to do this work. Multiply across, add down. Will they always give it to you set up like this? Hell no. So let's do a problem like that. And then let me see. Maybe one more problem, then I'll let you guys work on this little handout. So here's somewhere this is used pretty often. Let's say you've got a lot of money and they want to get $100,000 from you, an investment in some new startup company, right? Another rideshare program. No, we don't need another rideshare program, do we? And let's say they figured out that there's a 30% chance you'll break even. There's a, what you got, Jeff? I don't know, Jeff. 20% chance you'll lose all of it. And then there's a 50% chance you'll make in profit. What you got, dude? You can do it. $80,000. So you want to analyze your expected value. You want to. That's how you do a risk assessment. Right? I talked about that weird movie, Along Comes Polly, where they do risk assessment. So you could do this. If you're a gambler, you pay less attention to this. You just do it if you have a gut feeling. But you analyze it. So can I break this down into xp of x? This is not that far away from this already. So what are the possible outcomes? What's the first possible outcome? How much profit can I make
100,000?
here? How much profit can I make here?
0.
Zero, right? Zero profit. If I break even, I made zero profit. You guys got it with it? And how many, probability is just
0.3.
30%. I like it. This one, I'm going to lose $100,000. And there's a 20% chance of that happening. And then this one, I'm going to make $80,000, and there's a 50% chance. So this is a valid distribution because they add up to be 1. So whatever they give you in the problem, they're not going to give it to you set up in a table already, but it should be relatively easy to set it up. Here's an outcome, here's the probability. We'll do one more where you actually have to buy a ticket and you have to take that into account, the price of the ticket. This was written in terms of profit already, so they didn't have to do it that way. So now you just, I'll do it first. Yeah. This will be negative. You want to keep your negatives in there, of course.
Use 200.
No, what?
20,000?
No, it's 0.2.
Oh.
0.2, so it'll be 20,000.
Yes.
And then 0.5, so half of 80,000 is 40,000. Yeah. So my expected value is
20,000.
20,000. Now what that really means is if I had the same kind of deal, a lot, I would expect to make $20,000 on average. Since this came out positive, that normally would be looked at as meaning I should do it. Over the long run, I would make money. There's a chance I'll lose money. There's a chance I won't make any money. But at least the expected value came out positive. Every game in a casino, your expected value is negative. That's why they're running it. That's why they give you free booze. Because they got a lot of freaking money to buy crappy distilled, diluted booze and give it to you. Once you get a little bit less judgment go out the door. Okay, maybe. If it came out negative, I probably wouldn't do it unless I had some kind of gut feeling. I know it's going to work. Right? All right, maybe. All right, let's do one more with a price to play. Let's say, I sort of got one like this on the handout, so let me just do a little. Let's say they sell 100 tickets for $5 each. Thank God I don't handwrite my tests. And let's say there are going to be 3 prizes. One for $100, one for, I don't know why I keep writing one for $50, and then one is $10. Woo! I like this. This is some small time little fundraiser kind of deal. So it costs $5 to buy a ticket. Let's say you buy 2 tickets. All right, so here's the first place where we have to actually calculate our own probabilities. And it's not overly bad. I've got 2 tickets. Great, now I got 2 tickets there. So, what's the problem? What are all the things that can happen? How many total things are there that can happen?
3.
No.
4.
4. What's the 4th thing?
You don't win.
Lose. Loser. So you make $0. You get $0 back. So how much did you actually, what's your actual profit? That we bought 2 tickets. How much did that cost us?
$10.
$10. So if I win $100, how much did I actually win?
$90.
90. Is everybody cool with that? You guys see that? Here?
$40. $0.
Yeah, I just break even there. And then here,
Negative $10.
negative 10. Thank you, man. And now you just got to figure out the probabilities. If you can write it in this form, you can attack it like the other problems. So what's the probability I get the big prize?
Not very good.
Not really. How many tickets do they sell?
100.
100.
And you have 2 of them.
And I have 2 tickets.
So you got like a 1 in 50 maybe?
Yeah, there's a 2 out of 100 chance I'm going to win that one. And what's the chances I win this one? This 50 is $50. What sets up probabilities? Second? Yeah, this is 100 tickets. So the probability of any ticket winning $50 is 1 out of 100. So I've got 2 of those tickets. So it's 2 out of 100 again. And here again. Was probably I lose, I break even.
2 out of 100.
2 out of 100, yeah, because there's 1 ticket for that. And then what's probably I lose then? What's it got to be? Yeah, what do I have so far? 2, 4, 6. There it is. Because this has to add to be what? And it makes sense. If I buy 2 tickets, is it more or less likely that I lose if I buy 2 tickets?
Less likely?
Less likely that I lose. If I bought one ticket, these would all be 111. The probability I lose would then be 97 out of 100. But now it's 246. Probably loses 94 out of 100. Yes?
Wouldn't it depend on how they draw it too? Because if they draw out a ticket and it wins, don't you like have different chances after that? See what I'm saying?
Oh, okay. So what they're going to do is they're going to reach in and they're going to grab all the tickets at once. Yeah, we don't want to bring that in yet.
Yeah.
You're talking about like with and without replacement.
Yeah.
I'm totally with you on that.
Yeah.
So we're not going to worry about that yet.
Okay.
I like it. In fact, here they haven't drawn anything yet. Once they start to draw, I can start.
Okay.
Sort of like when you're playing poker. I know we don't all play poker in here, but the minute they've dealt cards, all the probabilities have changed.
Yeah.
But we haven't dealt any cards yet.
Okay.
We're just like before we even bought the tickets. We're just saying if I did buy 2 tickets, what would I expect to make on average or lose? How are we doing? So it's a good question. Thankfully, we don't have to bring that in yet.
Yeah.
We will. And now that I've got it set up like this, I just multiply across, add down, so I get, I like it. So let's write 1.8, 0.8, 0, and negative 9.4. Yeah. So what's that mean?
You don't have very good chances.
I don't have a good chance at all, man. Whoever made this lottery wasn't very fair about it, right? How much did it cost to buy? It was $5 a pair, right? So, let me see if you guys can. So I paid $10 for my 2 tickets, and I can expect to lose $6.80. Now let me tack on one extra idea onto this. What do you think it means? Do you think that's a fair price then? That $5 per. So $10 for 2 tickets. Is that a fair price?
No.
What would make it a fair price?
$3? $2?
Theoretically, not the correct, not the exact answer, but in general, how would I know it was a fair price if what happened? What up here tells me it's not fair? The minute we got
Negative?
here,
Yeah.
right? So how much did they charge too much? They charged $6.80 too much. So officially, a fair price would be one where the expected value is 0. That makes for a boring game, right? Gamblers wouldn't like that, actually, right? Oh, you guys kind of, it would never happen. Maybe that's why our brains rebel against the thought. Who the hell would do that? If you're setting something up, you're setting up to make money. I don't care who the hell you are. You got a little business, you're going to try to make money. You're not going to try to come out even. No, you got to make money. And I don't blame you. But if you wanted to make this into a fair price, instead of $10, how much should I have to pay for 2 tickets? $3.20. They charge this much too much, so the fair price would be $3.20 for 2 tickets. So how much for 1 ticket? $1.60. So if I redid this whole table with this being $3.20 here instead, and changing all these numbers accordingly, it would come out to be 0 here. 0. It would be a fair game. It would be a fair price. Okay, maybe. I don't know. All right. So let me give you this. If you need to borrow a calculator, they're up here. You can work together or be a wolf pack of 1. It's up to you.
Really want to work together. Trying to get some chicken nuggets here.
Chicken nuggets here.
Yeah, I'm all about the chicken nuggets. I don't know, they're craving like chicken tenders right now. Because the tenders, they're sometimes more crispy. Yeah, the tenders are more crispy. Depending on the place you go.
That was Billy Ball.
Oh my gosh. We got a little fork here.
Billy Ball.
Wow. Just pick a marble.
Did you make these bottles?
Yeah.